Toyota built a luxury SUV so over-engineered that it was too expensive to ever build again. Not because the market rejected it, because the accountants could not justify repeating it. The RX300 was done once, done right, and then quietly abandoned. Most people never knew the difference, because the story Toyota told the world was simpler, and simpler sold better. Everyone believes the same story about the first-generation RX300. It is just a lifted Camry. Same platform, higher ride height, luxury badge. The automotive press repeated it. Owners accepted it. Even Toyota's marketing did not fight the perception too hard, because platform sharing sounded like smart engineering. Pull the door sill trim on a 1999 RX300 and compare it to a Camry from the same year. Inside the sill structure, there is a steel reinforcement section that does not exist in the Camry. It is documented in the body repair manual cross-section drawings. The RX300 drawing shows an additional inner sill member. The Camry drawing does not. Toyota engineers added it because the higher roll center of the RX300 placed greater lateral bending loads on the sill during cornering than the lower Camry body encountered. Without that reinforcement, the unitized body structure would have been marginal under SUV loading conditions. This was not a part buyers would ever see. It was not mentioned in any marketing material. It was engineering doing what engineering does when the specification demands it. The platform commonality was real, but the modifications went deeper than anyone outside Toyota understood. The wheelbase stretched by 4.3 inches compared to the Camry. The floor pan received additional cross members welded into the structure. The front subframe mounting points were redesigned to accept higher vertical and longitudinal loads. Then there is the rear suspension. The Camry of this generation used a simple torsion beam rear. The RX300 used a double wishbone layout that does not appear anywhere in the Camry parts catalog. Toyota developed it specifically for the XU10 chassis because the combination of increased ride height, increased unsprung mass from larger wheels, and all-wheel drive packaging requirements made the Camry's simpler rear inadequate. That development cost money. Tooling for unique control arms, testing for geometry that had no carryover from existing Toyota vehicles, and suppliers who had to manufacture parts that served only one model line. This was engineering expenditure that would not exist in a simple platform carry application. The result was a body structure more complex in cross-section than a truck-based SUV, but heavier than a pure passenger car. It was a trade-off that produced acceptable torsional rigidity without the packaging penalties of body-on-frame design. It was expensive, more expensive than the market understood, and more expensive than Toyota could sustain once competitors arrived with simpler architectures that were good enough. The factory corrosion treatment followed Toyota's established practice. Galvanized steel was used in door panels and exposed underbody sections. A full undercoating was applied at the factory. Wax injection was used in closed body sections, including rocker panels and lower door frames. This was more comprehensive than most domestic competitors applied, but it had limits. Rocker panel rust became a documented long-term issue in salt belt climates, particularly where factory wax injection depleted and moisture entered through deteriorated door seals. The platform myth persists because there was truth in it. Window regulators, door handles, and heating, ventilation, and air conditioning assemblies came from the Camry parts bin. A Camry window regulator from an auto parts store fits the RX300's front doors without modification. That part's commonality created the massive aftermarket ecosystem that kept these vehicles economically serviceable 20 years later. But the structure underneath wasn't a Camry on stilts. It was something more complicated, more expensive, and more obsessively specified than the simple story suggested. If the body was overbuilt for safety and rigidity, the engine was overspecified for a level of smoothness the SUV world had not yet seen. The 1MZFE was an all-aluminum V6, both block and heads. Aluminum construction, when competitors like Mercedes-Benz still used iron blocks in their ML320. The weight savings were real. The RX300 came in at just over 4,000 pounds curb weight, which was light for a luxury SUV in 1998. But all aluminum construction came with a maintenance penalty that Toyota did not discuss at launch. The intake manifold was composite plastic assembled over a rubber gasket. In service, the gasket material degraded with thermal cycling. The port-injected 1M Fe intake geometry placed the gasket in a location that was difficult to inspect without partial disassembly. Coolant and oil seepage at the intake manifold gasket became a documented failure mode. Toyota issued Technical Service Bulletin EG014-02 in 2002. The bulletin addressed intake manifold gasket inspection and replacement procedures for 1MZ Fe-equipped vehicles. It specified a revised gasket material and updated torque sequence for the manifold fasteners. The TSB was issued to the dealer network, following warranty claim patterns showing elevated rates of manifold gasket seepage in the 60,000 to 80,000 mile range. This was not a catastrophic failure. It was a nuisance repair with a known fix, but it required professional diagnosis to distinguish from head gasket seepage, which was considerably more expensive to address. The revised gasket specification was incorporated into production vehicles built after the TSB issuance. 1999 through 2001 cars have the original gasket material that is more likely to seep. 2002 and 2003 cars have the fix already in place from the factory. Imagine being the second owner in 2005. A small green drip appears on the driveway. For a Mercedes owner, that is a four-figure nightmare requiring dealer diagnostics. For an RX300 owner, it is a known technical service bulletin with a documented fix and a predictable price. This is where obsessive engineering meets wallet-friendly reality. The overspecification created problems, but it also created solutions that independent mechanics could execute without proprietary tooling. Then there is the timing belt. The 1MZ Fe uses a belt, not a chain. The factory replacement interval is 90,000 miles. The 1MZ Fe is an interference engine. Belt failure results in valve to piston contact and catastrophic internal damage. Timing belt service is the most consequential scheduled maintenance event for this platform. Its omission accounts for a significant share of high-mileage engine failures. The water pump is belt-driven. Toyota service documentation recommends simultaneous replacement. The service interval is non-negotiable. Miss it, and the repair cost jumps from $800 to several thousand. The all-aluminum construction had another consequence. Head gasket integrity on the 1MZ Fe is adequate in properly maintained examples, but aluminum does not tolerate overheating the way iron does. A single overheating event that would be recoverable in an iron block engine can produce non-repairable head warpage on the 1MZ Fe. Overheating events caused by coolant loss, water pump failure, or thermostat failure cause faster and more severe damage. This is not a design defect. It is the physical property of aluminum under thermal stress. But it meant the 1MZ Fe required more disciplined cooling system maintenance than owners expected from a Toyota product. The coolant specification mattered. Toyota long-life coolant used a proprietary organic acid technology formulation. The factory service documentation explicitly warns that mixing this coolant with conventional green coolant causes a chemical reaction. The reaction deposits a brown, gel-like precipitate within the cooling system passages. The gel reduces coolant flow and accelerates corrosion of aluminum surfaces. Independent repair shops, unfamiliar with this specification, who topped off the system with standard green coolant, created conditions for accelerated corrosion. The damage would not manifest as an identifiable failure for 30,000 to 50,000 miles after the mixing event. The specification was not obvious from the coolant appearance. Toyota long-life coolant was also green in some formulations. The 1MZ Fe was a study in trade-offs. Aluminum construction saved weight but demanded precision in maintenance. The timing belt required discipline. The intake manifold gasket was a known weak point with a documented fix. But the real obsession showed up in the details buyers could not measure. Noise, vibration, and harshness suppression became a development priority for the RX300 in ways that made no sense for a vehicle marketed as an SUV. Toyota cared more about cabin noise than off-road capability. The engineering decisions reflected that priority. The acoustic firewall mass exceeded the Camry specification. Toyota's service manual for the XU10 RX300 documents acoustic damping material applied to the firewall and floor pan in a pattern and weight specification explicitly noted as exceeding the Camry and Avalon application. The additional material was applied in response to noise measurements made during development prototype testing. The higher seating position of the RX300 placed occupants' ears closer to reflected road noise paths than the lower Camry seating. The consequence was measurable. Without additional treatment, the RX300 would have been noisier inside than the sedan it was built from, despite costing $12,000 more. Pull the carpet out of an RX300 and the proof is visible. Thick bitumen-backed damping material covers substantially more floor area than equivalent Camry disassembly reveals. This was not a detail mentioned in marketing materials. It was engineering solving a problem that buyers would experience but could not articulate. The front subframe mounts used isolated rubber bushings instead of solid connections. The isolated mounts reduced the transmission of road surface irregularities into the cabin structure, but they added cost, complex assembly procedures, supplier coordination for parts that served only one model line. Period test results showed the outcome. Cabin noise levels in the RX300 measured quieter than luxury sedans at the same price point. Car and Driver's initial test noted the RX300 interior was quieter at 70 miles per hour than a BMW 5 Series of the same model year. This was unusual. SUVs of this era were expected to be noisier than sedans. The higher ride height, larger wheel wells, and increased wind noise from the taller body profile all worked against acoustic isolation. Toyota's solution was to add more mass, more isolation, and more cost. The approach disappeared in the second generation. The RX330, introduced for 2004, CUT acoustic treatment to meet price targets. The service manual for the XU30 shows reduced damping material coverage in the floor pan. The subframe mounts were simplified. Cabin noise levels increased measurably compared to the first generation, though they remained competitive in the segment. The obsession with silence extended to systems most buyers assumed were simple. The power steering pump on the XU10 generated a moaning noise during low-speed maneuvering. The NAHTSA complaints database shows a cluster of steering system complaints that predominantly describe this whine. Toyota identified it in pre-production testing as an NVH concern. Engineers addressed it partially through revised poor steering fluid specifications and a pump mounting bracket revision in 2000 production. But they did not fully eliminate it. The complaints did not reach the threshold for an NHTSA investigation because the noise was not associated with any loss of steering function. The issue was eliminated completely in the XU30 generation with a revised pump specification. The cost of quiet was real. Additional material weight reduced fuel economy. Assembly procedures increased production time. Engineering hours were spent on problems that could not be demonstrated in a showroom. But the result was a first-generation crossover that felt more refined inside than vehicles that cost twice as much. That pursuit of effortless refinement extended even to the way the RX300 put its power to the ground, using a system designed to be invisible to the driver, even when it failed. To understand how quiet the RX300 was, you have to remember what else was on the road in 1998. The Jeep Grand Cherokee hummed with tire roar at highway speed. The early Mercedes ML class had noticeable wind noise from the tall body profile. Even luxury sedans of the era accepted a certain level of mechanical presence in the cabin. The RX300 did not just feel quieter than its SUV competitors, it felt like it belonged to a different decade of refinement. That was not marketing exaggeration. It was the result of adding weight and cost to solve a problem most competitors did not acknowledge existed. The VF1, a viscous coupling, was Toyota's answer to all-wheel drive in a vehicle that started life as a front-wheel drive platform. The system was reactive, not driver-selectable. Front-wheel drive was normal operation. The viscous coupling transferred torque rearward when front-wheel slip was detected. There was no low range, no driver-controlled locking, no mode selector. The coupling itself was a sealed unit filled with silicone fluid. When the front wheels rotated faster than the rear wheels, indicating slip, The viscosity differential in the fluid caused the coupling to engage progressively. More slip meant more rear torque. Less slip meant the system backed off. It worked without driver input and without electronic intervention. This provided real traction benefits on low adhesion surfaces. Rain, light snow, loose gravel. The system gave the RX300 measurably better wet weather capability than the front-wheel drive variant, but it was not designed for deep snow or off-road use. The coupling could not sustain continuous high torque transfer without overheating. Extended off-road use would damage the viscous fluid. What is notable is the design failure mode. Toyota's engineers chose a fail-to-front-wheel drive architecture on purpose, and that decision was intentional. When the viscous fluid degrades beyond usable specification, which happens with age and high mileage, the coupling loses its ability to transfer torque to the rear axle. The vehicle then reverts to effective front-wheel drive operation, and it remains drivable in normal road conditions. This was not an accident. The alternative failure modes were fail-locked, which would bind the drivetrain and cause catastrophic damage, or fail-neutral, which would leave the vehicle immobilized. Toyota chose the failure mode that kept the car moving. For used buyers, the consequence is significant. High-mileage RX300 all-wheel drive models frequently have non-functional all-wheel drive systems. No warning light appears in early failure stages. No reduction in forward propulsion occurs. The car drives normally in dry conditions. Owners who purchase these vehicles often do not know whether their all-wheel drive system is functional without a specific diagnostic test. Replacing the viscous coupling requires removal of the transfer case. It is a labor-intensive service operation. The part itself is not catastrophically expensive, but the labor cost makes the repair uneconomical on a vehicle worth $5,000 in today's used market. Many high-mileage RX300s are effectively front-wheel drive vehicles that still carry the all-wheel drive badge. There is one more detail hidden in the AWD system that reveals Toyota's thinking. If you crawl under an RX300 and look near the spare tire well, you will find a small hose that has no business being on a vehicle marketed to suburban families. The rear differential includes a breather tube routed from the differential housing upward along the chassis to a point above the maximum anticipated water fording level. The tube is visible upon underbody inspection as a small diameter hose clipped to the underside of the body structure, terminating near the spare tire well. This tube prevents water intrusion through the differential vent in conditions involving deep water splash. It is a detail found in heavy-duty off-road vehicles, and it is unusual in a car-derived crossover whose marketing did not emphasize off-road capability. But it is there, engineered into a vehicle that most buyers would never take off pavement. That specification proves Toyota was building beyond the market, not just to it. Platform commonality became the RX300's survival strategy, not at launch, but 20 years later, when the vehicles entered the used market and faced the reality of aging components. Window regulators fail, door handles break, heating, ventilation, and air conditioning blower motors wear out. These are predictable failures on any vehicle with 15 years and 200,000 miles of use. What matters for long-term survival is whether replacement parts exist at prices that make repair economically rational. A Camry window regulator from AutoZone fits the RX300's front doors. No modification required. The part number cross-references directly. The price is $45. The same part from a Lexus dealer in Lexus packaging costs $130. The parts are identical. The Camry's massive sales volume created the aftermarket ecosystem that made that $45 price possible. The 1.0 FE engine was shared across Camry Avalon, ES300, and RX300. Any independent mechanic qualified to work on a Camry could service the RX300's engine without additional training. The timing belt service procedure is functionally identical. Coolant system service follows the same steps. Valve clearance inspection uses the same specifications. Accessory drive service requires the same tools. This familiarity substantially lowered per-service cost compared to a vehicle whose drivetrain had no passenger car counterpart. The timing belt service on an RX300 at an independent shop runs $700 to $900. The same service on a Mercedes-Benz ML320W163 the RX300's primary competitor at launch, requires dealer-specific tooling and runs $1,300 to $1,800. The parts commonality extended beyond the engine. The A541E transmission was used in Camry and Avalon applications. Transmission fluid, filters, solenoids, all available from the same aftermarket suppliers serving the high-volume Camry market. The front suspension struts, wheel bearings, and steering rack components were cross-referenced to Camry parts. Compare this to the Mercedes-Benz ML320. The ML320 used a conventional architecture adjacent to a ladder frame, assembled in Alabama. Early production quality was widely criticized. Differential failures occurred. Electrical system reliability problems emerged. Brake system issues required dealer-specific tooling to diagnose and repair. Parts commonality with other Mercedes-Benz vehicles existed, but at price points reflecting Mercedes-Benz parts strategy rather than Toyota's volume-driven ecosystem. A replacement differential for an MNL320 cost 3 times what an RX300 rear differential cost. The labor rate at a Mercedes-Benz dealer exceeded independent shop rates by 40 to 60%. The consequence shows up in survival rates. ML320W163 examples in the used market at equivalent mileage are substantially less common than RX300 examples. This pattern is observable in used car inventory data from the mid-2010s onward. The vehicles that survived were the ones whose failure modes were predictable, non-catastrophic, and serviceable by independent shops at reasonable cost. The RX300 failure modes met that criteria. The timing belt was high stakes, but it was a scheduled maintenance event with a known mileage interval. The intake manifold gasket seepage was a nuisance failure with a documented fix. The all-wheel drive viscous coupling degradation was gradual and did not strand the vehicle. Front-wheel drive remained functional as the coupling failed. This profile of failure modes, predictable, non-catastrophic, and serviceable, was favorable for long-term survival. The parts commonality with the Camry made that serviceability economically viable. An RX300 with 200,000 miles could justify a $1,500 repair because the vehicle retained utility value. An ML320 at the same mileage could not, because the next failure was unpredictable and the repair cost was prohibitive. The unintended consequence of Toyota platform sharing strategy was a luxury SUV that remained economically serviceable long after its competitors had been scrapped. But the very things that made the XU10 a legend for second and third owners, the overengineering and unique structural costs, were exactly what the accountants were determined to optimize for the next generation. The second generation RX330 arrived for the 2004 model year. New sheet metal, a 3.3-liter engine replaced the 3.0, a 5-speed transmission instead of the 4-speed, more electronic content, more standard features. What changed underneath told a different story. The acoustic treatment was reduced. The service manual for the XU30 shows less damping material coverage in the floor pan compared to the XU10. The subframe mounts were simplified from isolated rubber bushings to a less complex design. Parts commonality with the Camry decreased as Toyota moved the RX toward a more differentiated platform architecture. Each subsequent generation continued this trajectory. The third generation RX350, launched for 2007, added electric power steering, pre-collision systems, and Quian bus architecture. The mechanical simplicity of the first generation's hydraulic steering disappeared. The electric system eliminated the power steering pump noise complaints, but it introduced ECU-dependent failure modes that didn't exist on the XU10. The market reality drove these changes. Competitors arrived with lower-cost architectures that were good enough. The Mercedes-Benz ML320's production problems created an opening in 1998, but that opening didn't last. BMW launched the X5, Acura introduced the MDX, Cadillac brought out the SRX. The segment matured, margins compressed. Toyota faced a choice: continue the XU10's obsessive specification, or meet the market's new price expectations. The cost structure that made sense in 1998 didn't make sense in 2004. The hidden steel reinforcement in the door sills cost money. The custom rear suspension cost money. The excessive acoustic damping cost money. None of these things could be demonstrated in a showroom or quantified in a specification sheet. The evidence appears in the service manuals: reduced damping material, simplified subframe mounts, fewer unique parts. The second generation was still a well-engineered vehicle. It was still reliable by industry standards, but it wasn't engineered to the same invisible standard as the first generation. The thesis is proven in the comparison. Toyota achieved a genuinely new vehicle category by applying over-specified passenger car engineering to a product that had never received it. The luxury car-based crossover did not exist before the RX300. Mercedes-Benz tried with the ML320, but compromised on quality. Land Rover offered luxury, but used truck architecture. The RX300 was the first to deliver car-like refinement in an SUV package without the compromises. But the cost made the identical approach impossible to repeat. The margin structure of the luxury SUV segment in 2004 could not support the engineering expenditure Toyota had absorbed in 1998. The market had moved. Competitors had established that good enough was actually good enough. Buyers did not demand the invisible over-engineering that Toyota had provided. The first-generation RX300 stands as proof that something could be built to a standard the market would not pay for twice. We often talk about the good old days of car building. Usually it is hyperbole, nostalgia distorting reality, but with the XU10, the spreadsheets actually prove it. The service manuals document it. The part specifications confirm it. The RX300 proved perfection was possible. It also proved perfection was unsustainable. But here is the paradox. These vehicles are still on the road today, still delivering the refined, over-engineered luxury experience that Lexus attempted once and then abandoned. The forever machine outlasted the future it was meant to create. While competitors from the same era have been scrapped for parts, the RX300 continues to serve families who value substance over features, weight over technology, intentionality over optimization. The question Toyota could not answer in that executive meeting hangs in the air still. What happens when perfection becomes too expensive to repeat? We are living in the answer. The vehicles that were too costly to build twice became the vehicles that never needed replacing. If this kind of engineering obsession interests you, the Lexus LS400 is the next place to look. That is the car that started it all. It is the one where Toyota handed engineers a blank check and told them to beat Mercedes and BMW at their own game. The philosophy behind the RX300 was born there. Watch that video next.